Okay, so we're on problem 39. Again, we're given 2 points, but this is one of these cases where we have the same x or same y coordinate for both cases. So you see we have 2, 5 and 1, 5. So the y value doesn't change, and hence the equation is going to be y equals whatever that number that doesn't change. So if x doesn't change, then it's x equals. Y doesn't change, it's y equals. Okay, 42, similar kind of thing. 13, 5 and 13, 1. So this is the other case, -1. So x is the same. And you know, if we didn't recognize that immediately, what we would find is when we calculate the slope, we would get some number divided by 0, because y2 minus y1 would be 0, which is undefined. Undefined means vertical line. Actually, it's the other way around. Y is in the numerator, so it'd be 0 over some number. This is y2 minus 1, so this is 0. So a slope of 0 is this, and that's a horizontal line, which is y equals 5. But it's probably easier just to look at these before you try anything. Check to make sure they're either vertical or horizontal. Now here we have the same x value. So since x doesn't change, it's just x equals 13. Again, if we did the slope, make sure I do it right this time, y2 minus y1 over x2 minus x1. In this case, x is the same. x1 and x2 are the same, so you get 0, and there would be some y, which in this case would be -6, but it doesn't matter. Any number divided by 0 is not infinity, but it's undefined. And an undefined slope is vertical. Okay, 45, find the equation in the slope-intercept form of the line satisfying the given conditions. This is actually pretty easy because what they give you is m, which is the slope, and b, which is the y-intercept. And so you can really just plug it into the form, the y-intercept form, which says y equals mx plus b, where m is the slope and b is the y-intercept. So all we have to do is say y is equal to the slope, 5 times x, plus b, which is 15. The next one we have slope, m equals -5/8, which means the slope's 5/8. And we are given that b is equal to -1/3. So again, write out the slope-intercept form, and then just plug in the numbers. Okay, we're going to skip over a few here. We'll go to 53. It says, write each equation in the slope-intercept form. Give the slope of the line, give the y-intercept. Okay, so that's pretty, once it's in the slope-intercept form, you just have to identify this as being the slope and this as being the y-intercept. This form is actually called the standard form, which is not that useful. They say the standard form is ax plus by equals c. So in this case, a is 1 and b is 1. C is 12. So the more useful approach is you solve for y. So to solve for y, we want to get this x to go to the other side. To do that, we're going to subtract x from both sides. So x minus x is 0. That means I solve for y, and I get -x plus 12. And I put it in this order because that's the standard, that's the slope-intercept form. So all I have to do is just look. So here, of course, the slope is not negative. Anytime it's a negative means it's -1. And b is equal to 12. Okay, 56, similar kind of thing. 6x plus 5y is equal to 40. Again, we're going to subtract whatever the x value is from both sides. That goes to 0, so we're left with 5y. And again, I'm going to put the x term first and the variable term second. Now, we're not quite done. The slope-intercept form always requires that the coefficient in front of y be 1. So just like we did in Chapter 7, we had to divide everything by the same number. So we don't just divide 1 by 5, we divide everything by 5. So on the left-hand side, 5 divided by 5 is 1. So we get 1y. And then we have -6/5. So I create a separate fraction just so that we know that's the slope. And then the second one is what the heck are they called? Not irrational, but improper fraction. But in this case, actually, you can simplify it because 40 is divisible by 5. So we get 8. So therefore, m, the slope, so that's the answer for the first part. That's in the slope-intercept form, so you just have to look at the coefficient in front of m, that's the slope, in front of x, and b is the other constant that we have left over here. So the slope is -6/5, and the y-intercept is 8. Okay, write equation slope-intercept form of the line satisfying the given conditions. So it's through this point, 7, 2, and it's parallel to this line. So the way we've had problems where we're given the point and the slope. So we need to find the slope from this second bit of information. And because they're saying parallel, parallel has the same slope. So if I can find the slope of this equation, then I can say the slope of this equation is the same as the slope of that equation. And the rest is like we did in a couple of other problems. If it's perpendicular, which is not this problem, but if they ask perpendicular, perpendicular lines have slopes which are negative reciprocals of each other. Reciprocals of each other. So if you have a slope that's 5/7, the negative reciprocal is -7/5. I put a negative sign out in front and I flip it around. If I have -3/2, the negative reciprocal is +2/3. I take the reciprocal, which means switching the numerator into the denominator, and I change the sign. If I had 1/3, the negative reciprocal would be -3/1 or -3. If I had a slope of -2, this is the only time you rewrite it, is you have -2/1. So the reciprocal of 2/1 is 1/2, and this negative changes to positive. So that's the different cases to go from one to the other. So if you get a problem like that, you'll know what to do. Okay, so the one we're doing is 59. So what we have to do is we take this second line and we have to find the slope. And the way you do that is put it in the slope-intercept form. So we're going to add or subtract 3x from both sides. That's to isolate the variable term, the y term. So we're going to subtract that from both sides. So that's going to go to 0. 3x minus 3x is 0x, which is 0. And then you bring the negative y down. So we get negative 3x plus 8. And we add these two together. And then you divide by negative 1. So you get positive y is equal to positive 3x minus 8. So the slope of the line 3x minus y equals 8 is 3. So now we have the slope, so now we basically go back and we say we have the point, which is 7, 2, and a slope equal to 3. So then you use the point-slope form of the linear equation. This is my point. This is my slope, so let's just plug them in. Y is the variable. Subtract y, which is 2. Slope is 3. x1 is 7. So that's the point-slope form of the linear equation. Then we want to put it in the slope-intercept form. So first thing we're going to do is we're going to multiply, get rid of the parentheses. 3 times x is 3x, 3 times negative 7 is negative 21. Then we're going to isolate the variable term. Y minus 2 plus 2 is just y. Here we get 3x minus 19. So that's the equation of the line that goes through this point, but it's parallel. Use the fact that parallel lines have the same slope. Okay, let's skip over. We're going to do some two word problems. So problem number 70 says, it's on page 387, so make sure you pull it out. The table gives the heavy metal nuclear waste in thousands of metric tons from spent reactor fuel stored temporarily at reactor sites awaiting permanent storage. And they give you the source. And then they give you a table of year versus waste in thousands of metric tons. So it says, let x equals 0 represent 1995, x equals 5 represent 2000, and so on. Use 0, 32 and 25, 76. So the first pair represents 1995 data, and the second pair represents 2020 data. To find the equation of a line that approximates the other ordered pairs. So what we're going to do is we're going to assume a linear change between the beginning and the end. So we're going to use the two endpoints. Now there is another way of doing this. When we get to statistics, you can do what's called a regression, which actually would take into account the other years as well. But that's not what they're asking here. So basically what we're doing is we just take the problem and we rewrite it as 0, 32, which is 1 point, and 25, 76 is the second point. So this is x1, y1, this is x2, y2. So what we do is we first find the slope. Using the slope formula. So y2 is 76, y1 is 32, x2 is 25, y1 is 0. So that's 44 divided by 25. Now you can't simplify that because you can't divide 44 by 5, and that's the only factor, 25. So that's my slope. And so let's, so now we do just take one of these points. It doesn't matter. This one's the easiest one because one of the terms is going to go to 0, one of the x1 or y1. So this is the point slope form of the linear equation. Y1 is 32. M is 44 over 25. X is the variable. X1 is 0. So we get rid of the parentheses. And then you're going to add 32 to both sides. And that's your final answer. The book actually puts this number as a decimal form. So I'm going to put that, get my calculator out for that. Oh, there it is. .76. If you look in the back of the book, which actually this one's not in the back of the book, but they just show you this equation. Okay, part B says using the equation from part A to estimate the amount of nuclear waste in 2008. So, second part B, 2008. We wouldn't stick 2008 in there because we used 0 and 25. So we have to figure out what 2008 is relative to the first date, which is 1995. 1995 corresponded with 0. So that's 13. So we're going to use 13, which you can see is between 0 and 25. And so to find Y, which is the heavy metal nuclear waste, all we have to do is take the linear equation, plug in 13, and see what we get. 1.76 times 13 plus 32. That's 54.9 or 54.88 thousand metric tons. What is a metric ton? Well, 2,000 pounds equals 1 standard ton. 1,000 kilograms equals 1 metric ton. And it turns out 1 kilogram is 2.2 pounds approximately. So 1 kilogram is equivalent to 2,000 pounds. So you see a metric ton is going to be about 10% more than a standard ton. Okay, and the last problem is 74. So same kind of deal. We're probably going to be given some information and come up with the equation. So we have air conditioning choices. The graph shows the recommended air conditioner size in British thermal units for selected room sizes in square feet. Use the information given for rooms of 150 square feet and 1,400 square feet. Let X represent the number of square feet and Y represent the corresponding BTU size air conditioner. Find a linear equation that models the data. Write it in slope-intercept form. So it's really the same thing. Again, we're taking the initial point, which the X value is 150 and the Y value is 5,000. And the final X value is 1,400 and the Y value is 24,000. And what they're doing is assuming it's linear. Looks a little not quite linear. So this would be, I think it's going to over-predict some intermediate condition, but it's still an estimate. It's not too bad. So x1, y1, x2, y2. So the slope y2 minus y1 over x2 minus x1. y2 is 24,000. y1 is 5,000. x2 is 1,400. x1 is 150. So I'm just going to do this in decimal form. So 24,000 minus 5,000 divided by 1,400 minus 150. You got to make sure you do the 1,400 minus the 150, and then you can divide the whole thing out. If you use your calculator wrong, you might mess up. So really, what we have here is 19,000. 24,000 minus 5,000, and then we have 1,250. 1,400 minus 150. And the answer was 15.2. So that's the slope. So once you have that, then you use the point slope form of the linear equation. Again, it doesn't matter which one you use, so I'm going to use the smaller one. So our variable is y. y1 is 5,000 from here. Slope is 15.2 times x, which is the variable, minus x1, which is 150. So multiply out on the right-hand side, so you get 15.2x. And then you have 15.2 times 150. 15.2 times 150 is 2,280. And then we want to solve for y to get in the slope-intercept form. So we're going to add 5,000 to both sides to make this go to 0. So you get y is equal to 15.2x plus, so we get 5,000 plus a negative 2,280, 2,720. And if you plug in x equals 150, you should get 5,000. Let's just try the 15.2 times 150, which is 2,280, plus 2,720 is 5,000. If you plug x equals 1,400, you should get 24,000. So 15.2 times 2,400 plus 2,720. Oh, something's wrong there. What did it do? Oh, 1,400. I don't know why I said 2,400. 15.2 times 1,400. That's the second point. Plus 2,720. You get 24,000. So that does work. So that's my final answer. That's the final problem for this section.